So we just came up with two important theorems that sine theta over theta, if we look at the limit as theta is going to 0, this is equal to 1. And we saw the limit as theta goes to 0 of, gosh, what was it? 1 minus cosine theta all over theta is equal to 0. So keep those in mind. We might need to use those. And so let's look at an example of a limit of a trigonometric function. And so let's say the limit as x is approaching 0 of tangent of x all over x. So right away, direct substitution, I would get tangent of 0 all over 0. Tangent of 0 is 0 over 0. So again, that doesn't tell us anything. It's in indeterminate form. So we got to go back and manipulate. So let's try rewriting tangent in terms of sine and cosine. So we could rewrite this if we wanted to, right, as tangent of x, if it helps you to look at it this way, all times 1 over x. But tangent of x, so limit as x goes to 0, was sine of x all over cosine of x, all times 1 over x. Well, that's the same thing as the limit as x goes to 0. I see a sine x over x here. Same thing as sine x over x, all times 1 over cosine of x. You can look at the limit of the first piece times the limit of the second piece. Well, the limit of the first piece is 1, all times 1 over cosine of 0. Again, cosine of 0 is 1, so this is 1 times 1. So this is equal to 1. So we're looking at a different example. How about the limit as x is approaching 0 of sine of 5x all over sine of 6x. So we want to kind of manipulate this so that we can get a sine of ax. Doesn't matter what the coefficient is, all over ax. So the argument of our sine should be the same thing that we're dividing by in our denominator, and this would be 1. So our goal is to manipulate it to look like this. Well, let's do this by a fancy one. How about let's multiply that denominator by 5x over 5x. And let's multiply this numerator by 6x over 6x. Sorry, denominator. So if I rewrite this, this is the limit as x goes to 0. Think of it as 5x. I can pull that in front of my sine x, sine of 5x, all over 5x divided by, so distributing, I have 6x sine of 6x all over 6x. So limit x goes to 0. So let's we kind of want to separate this 5x in here. So let's pull it out front. So I have 5x, right? All times sine of 5x over 5x. All over, let's pull the 6 out, x out, of sine of 6x over 6x. So we have rules that we can break this up as a limit of the denominator or numerator over the limit of the denominator. It's product of functions. We can look at the limit of the first times the limit of the second. So technically we have, and maybe we could just do this. This might even make it easier. Let's look at this limit 5x over 6x times the limit x goes to 0 of this piece. Let's do this, sine of 5x over 5x all over the limit as x goes to 0 of sine of 6x over 6x. I'm just using the properties of limits that we've talked about in the past. Unfortunately, that first piece, if I plug in that 0 for x, I get 0. And so 0 over 0. And so notice, though, that there's two factors that cancel those x's. So if I'm looking at the limit as x approaches any number of a constant, that's just equal to that constant. So this limit as x approaches 0 of 5, 6 is 5, 6. All times, well, the limit of this numerator, x approaches 0 of sine of 5x over 5x is 1. And the limit of this denominator as x goes to 0 of sine of 6x over 6x is also 1. And so we find that the limit as x approaches 0 of that function, sine of 5x over sine of 6x is equal to 5, 6. So looking now at the example, the limit as x is approaching 0 of sine of the argument is x squared all over x. Okay, so recall there's a difference. Sine of x squared like this, sine of x quantity squared. This is the same thing as sine squared x, but these two are not the same. So we want that argument to be the same in the numerator and denominator. And so I need that to be an x squared down there in that denominator. So we can manipulate it by, again, multiplying by a fancy 1. I know, so again, if I do direct substitution, I get 0 over 0. So let's multiply the top by an x and the bottom by an x. So if we do that, we now get the limit as x approaches 0 of x, I'm going to put that in front, sine of x squared all over x squared. Think of it as breaking it down as the limit of those products. And so if I look at the limit as x is approaching 0 of x times the limit as x is approaching 0 of sine of x squared over x squared. So this right here is 0 times this limit, which is 1, and 0 times 1 is 0. So I want to just do one more example, almost identical. But this time it's the limit as x goes to 0. Instead, we have a sine squared x all over x. So sine squared x, I call is sine x times sine x. So we can rewrite it as the product all over x. Manipulate it so that we get that form sine x over x. We can bring it down to both of those pieces. So sine x over x as x goes to 0, that is 1. All times sine of 0. But sine of 0 is 0, so we have 1 times 0, which in this case is also 0.